Hi there! This video series is to display my problem-solving and learning abilities. I hope to show that I can solve any programming problem, regardless of whether I already have expertise in the language at hand. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. For now, I am learning Python. I have no professional experience or formal training in the language, and have only been learning it since mid-January. While I'm picking up fairly quickly, I cannot claim any real expertise. Today, I am going to show my approach to solving the 11th Project Euler problem, starting fresh and talking through my thought process. As always, I will link to both Project Euler and my repository in the description. Let's dive in. Okay, problem 11 is the largest product in a grid. In the 20 by 20 grid below, 4 numbers along a diagonal line have been marked in red. The product of these numbers is this. What is the greatest product of 4 adjacent numbers in the same direction, up, down, left, right, or diagonally, in the 20 by 20 grid? Okay, so here's my first thought. This we should probably represent as a 2D array. It's probably not called that at all in Python, since arrays are called lists, but that is the concept, as it would be called in Java. And also, product of 4 numbers does not depend on the order you multiply the numbers in. So it's giving us a little bit of misdirection here by saying check up and down and left and right. We basically only have to check 4 numbers that look like this, or 4 numbers in the same column next to each other, or the diagonals. Checking the diagonals is going to be a little bit tricky. Let's open the little thing, this little thing. Oops, I clicked it twice. Okay. Create problem 11 dot py, and perhaps, oh, it looks like Visual Studio Code is smart enough to order these in the way that I want them to be ordered, instead of like many Windows programs I've seen in the past be like, I want problem 11 before problem 2, right? So that's kind of neat, isn't it? Okay, for this particular case, I actually don't like this any better than the copying and pasting and then retyping some numbers that I've been doing, but that's okay. Let's see. Can I kind of... yeah, that's what I want. This is the boring bit, because what I think I want to do is create this 2D array kind of manually, which means I'm going to be typing commas for a few minutes here. Let's see, so I'm just going to call this grid, and that's going to equal all of this. So let's see, can I think and type at the same time? So obviously, and again, pretty sure there's going to be a better way to do this, but just getting the data in shape here. So we want to be able to find all of these different combinations of 4 numbers that are adjacent. There's a few different ways that we could approach the problem. I'm not sure why this is, like, not working the way I want it to. What if I do this? Okay, so all those ones where it's highlighting in red, it's because it was like, you don't need this leading 0. What you doing? I'm not sure why the double 0 gets a pass. We'll go ahead and do that too. Okay, so now I'm thinking there's a better way to do this. There's gotta be a better way to do this. Let me just mash Control Z for a little bit here. And instead of all of this noise, let's make this grid be an array of strings. And actually, let's just call this lines. And then we can use Python to manipulate this data. And have it create our 2D array for us. Again, there's definitely a better way to do this. I'm just not certain what it is, and like this part's not super important, because this is just about, hey, let's get it to the point where like we can actually use our data here. There we go. Starting to shape up. Okay, so there's our lines. And then for grid, let's see if we can do a list comprehension. Let's see if I remember how to do that. So, let's see. Wrong character. So what we want is line dot lit. Ooh. Or actually, let's see. Let's do an inner list comprehension, maybe? Sorry, I'm not talking through this super well. So what I'm trying to do is make it so that these are actually integers. Int. Int. Number. For number in line dot lit. Because we want to split on the space, I think we're fine just leaving it like that. For line in lines. So what I think this will do is give us our 2D array or equivalent 2D list, our list of lists, because this says for each line in lines, give us an array of the int with the int version of the number after splitting the line up. Let's just go ahead and do a little print. Nothing wrong with doing an extra print to make sure you've got your data structured right. In fact, I think it's a real good idea the vast majority of the time. You can never really trust that your brain has all the details down. Okay, and it's definitely doing a 2D array, and it's looking right. That looks like what we want. Excellent, cool. Now we don't want to print the grid anymore. And again, let's go ahead and steal our little date time things so that we can know how long it took to run this for sure. I don't know why I went back to this one, because obviously I could just copy it from above the file. That's fine. Okay. So we need a max product equals 0. And then we're going to want to print that max product because that is going to be our answer. Okay, so let's see. How would we go about doing, well, the left and right's easy. It's just any four digits in a row, 4 numbers in a row in any of our interior arrays. So we can do a for hate to overuse variable names this month, but hi KitKat. For line and grid, and then for I in range line dot. Nope, it's not line dot size. Not in Python. Length of line minus 4. Product equals line I. That's a 1. Line I times line I plus 1 times line. I'm fairly certain that Java has some cute little methods built in that would shall we say... Maybe it's just 3. Let's do it as 4, and let's do some prints to make sure. So for each line, that's confusing, but our last entry should be these 4 numbers multiplied together, which is, if we go to our handy dandy calculator inside of Google, or I should say inside of Chrome, but... Okay, so for this is our last number printed out by this print statement. It means that I am seeing all of the numbers that I expect. And I'm just going to go ahead and throw a little comment right there. And then if product is greater than max product equals product. And this alone should give us all of the left to right adjacent products, which obviously isn't going to be the correct answer, except perhaps by happenstance. Let's see. We did not get the correct number. That's for sure. So this last one is a 0. Or, well, the last one is this. Why is product not... Oh, well, probably because I didn't finish typing this line where I set max product equal to product. That's my guess. And let's cut this down to -3 so that we're getting everything. Okay, so our max product so far is this number, and we have this number, so we no longer have an off by 1 error, so we're golden. And that is calculating left to right. Okay, so I'm going to go ahead and do this in a very simplistic way. So I in range length of grid. So now I'm going to try to get the up and down. I typed the word length out unnecessarily. Okay. So we're gonna go through every line in the grid. Okay, so how do we want to do this? Well, the way that I think of doing it is we start with this element, we look at it multiplied by these elements. We could go this direction. So like these as the starting elements, and then these, and then these. Or we could go like down. And I think with this particular outer piece, we're gonna want to go down. Because the iron range... No, the iron range is going to be the row. So, prime range length grid, line equals grid I for k in range. Length of the line minus 3. Okay, so we have our little grid. And we're going to be changing... Okay, so we're going to start and go this way with our leading numbers. So, product will equal... And you can kind of already see that I'm doing some duplicate work here. Because this is identical to this. So we're going to want to merge these two, but let's get all the logic out there first. Line k times... And yeah, that's just fine. Grid I plus 1 times grid I plus 2 times grid. Hopefully after next week I'll be back to typing at least a little bit faster. And then if this works the way that I want it to, what it's going to be in the last product, 36, 16, 54, 48. That's 48. Okay, so yoink. Yep, double check that that's what we want. Make a tiny little note just so we have a way to double check ourselves. And then again, we have if product greater than max product is going to equal product. And again, as you can already tell, duplicate code going on over here. Oh no. Oh, well. Yeah, that's valid. This is why we double check as we go on. I mean, honestly, it would be probably best to do this sort of thing with some tester in development. It is one of the better ways to make sure that you're getting good code. Okay. So. We expected the second to last number printed out to be 1492992. But that isn't what we're getting. So let's make this log a little bit more. Well, I chose K instead of J. That's unusual for me. No. Product. Okay, so we're hoping that the very last one is going to be, let's see, if that's a zero index, then this would be 1919. So 1819, 1719, 1619. Let's see. Okay, so what we're doing here is we're stopping early, aren't we? So position I, 16. And K, 16. We don't need our -3 here. That's what's going on. So it's not the same condition. I still think we can probably merge this in. These two for loops, or I guess 3 for loops. We can definitely make these more efficient. I don't see how just yet, but okay, I16, K19, that's what we want. So now let's leave that print statement for a second and think about diagonals. How do they work? Let's see. So each item on the grid has a potential diagonal attached to it in either the I+1 and a J+1 direction, or the I+1 J-1 direction. So let's go ahead and do another for loop set. And obviously, as you can tell, this might work for our 20 by 20. It's only 400 numbers. It might be efficient enough, but there's no way that this is a good enough algorithm. It's like n squared times 3, or n to the 6th, maybe. Is that accurate? I don't know. It's n squared plus n squared plus n squared, so 3n squared. Not efficient. And then we'll do length of grid minus 3. Line equals grid I, just like above. And this time we're actually going to use J, and we'll maybe smash those top two into this bottom one as possible. We shall see. We're not there yet. The line, and this one again, we want to be very careful, I guess. And then let's see, so for this one, we're going to have line of J times grid of I+1 at position J+1. Oh, should probably guard this with an if J less than or equal to length of the line minus 3. Then we want to calculate this product. Let's do a nice tiny little method here where we just say def I'm going to call it check replace product, which is a bad function name, because it indicates that this function does two things. And I don't know why I'm going to bother typing this again. It's just this. It's just that. Don't need a return. Yeah. And then we can replace these with just chuck replaced product. And we don't even really need to have product separated out. But since it makes our lives a teeny tiny bit easier, I think it's fine. I think it makes the code just slightly the tiniest bit more readable. Okay, so times grid I plus 2 k, wow, j plus 2 grid I plus 3 j plus 3. I'm willing to bet that in PyCharm it would have been like, I got you, and done most of that for me. And then if j greater than or equal to 3. So if it is greater than or equal to 3, then it is the fourth item, because 0, 1, 2, 3. Which means that we can go backwards. And it's important that this not be like an if-else if, because we actually want both cases. So we basically want this again, except negative signs for these ones. The grid, we're still going down it, so it's fine. That's not what I meant to type. And then one more call to that, check replace product. Okay, so we come in here, we're going through these numbers. This is going to be the last line we start at. And the last product is going to be 36 times 36 times 57 times 89. 36 times 36 times 57 times 89. This is why I kept that line, is so I could yoink it and put it down here. Okay, so obviously we're going through the entire array 3 different times, and that's less than ideal. Okay, I know how to fix that, though. We just say global max product. Interesting. So length minus 4, perhaps? Yeah, that makes sense because... No, it doesn't. Okay, let's look at our grid again. So... we can't go forward if we are past here, which is the index. Let's see, 19, 18, 17, 16 of length minus 4. Ah, if I did less than, I could do minus 3. Okie dokie. I'll check. Okay, so this should actually be our correct answer. But before we go check it, let's first get rid of this annoying print line. Make our data a lot less noisy. And as you can see, that ran in 1/100 of a second, real fast. But let's see if we can at least make our code a little more efficient. Let's see, when we first ran it, did it also go similarly fast? 16, 59, 36, 1, 2, 3. It had to have taken a little bit longer just for printing all of this out. Dang. 16, 59, 36, 0.08. So still well under a second, which is obviously much less than the minute timeline that we're given. Okay, so I am going to try to merge these different for loops here. So for I in range, length of grid. So instead of having the I stop like that, we're going to do that. And actually, we're still going to have the same for J. And then if I put parentheses around my checks in these ifs, and they do not need them because this is Python. If I is less than grid minus 3, then, or instead of less than, make it greater than or equal to. No, because yeah, if it is less than, then we want to do basically these two checks. If it's greater than, we only want to do this one. So let's go ahead and do that one first. So if J less than length 9 minus 3, do all of this. Okay, and that's our first one incorporated. Then I can say if I is not all the way at the end there, then I want to check Okay, so for this one, it's all of them. So let's go ahead and copy paste this exact thing. And then these two. Have this. Obviously, I'm doing the same check kind of twice here, but I think it is worthwhile in this case because we want to try to keep the code readable. Because what if I look at this in 6 months and I have no memories? A sadly accurate representation of events, frankly. Okay, so obviously we are still going through every single combination manually, etc., etc. It's still an O of n to the second. But this should, let's see, let's assume for this exact second that this is the correct answer and save it here. Okay, unsupported operand types 4 minus. Oh, well that's just a case of me not putting the parentheses in the right spot. That's my bad. This is exactly why I copied it instead of being like, it'll run fine. It never runs fine. Okay. What's going on here? It should all run as the same if statement. Okay, so we got line I. Oh. So this actually has this condition as well. Ah, I know what's going on here. These should be J's. That's what I get for, like, modifying my variable names all over the place and not double-checking myself. Okay. So now, maybe, we got a number, and it's the same number we got before we touched our code. And it is still taking what is that, a thousandth of a second? Crazy. I keep saying it, but Python feels like cheating. It is so fast. Alright, okay, so greatest product of 4 adjacent numbers in the same direction in the 20 by 20 grid. Did we get it right? We did! Alright, so in this case, the naive approach was both very, very efficient for the size of data that we were working on a bigger grid. It wouldn't have been so efficient. And there's not a little document with a little helpful hint saying, hey, here's a faster way to do it. So I think we knocked this one out of the park pretty well. And I'll catch you all in the next one.